Hello everyone, I'm Ciaran, and I want to talk about, hi Frank, I want to talk about Behat best practices, and like all best practices, you can argue with them. It's just sort of my opinion of what's working for me, and you know what I think the best way of using this tool Behat is. Who's using Behat already? Oh wow, great. So if you haven't used it, I think there's enough introduction about what it is and how to use it. So let's go back a step. What's software development about? So someone has a business problem, and if you can get them to sort of start talking about their business problem in terms of projects or stories or epics or milestones. They have some problem. The best way to talk about these things is, you know, what you're trying to change, what you're trying to achieve in the world. There's something you want to happen, or something you want to stop happening, or something you want more of to happen. And then through conversations, we come up with solutions to these problems. Now, developers might not be involved in all of those conversations. I tend to think they should be. But we come up with some business solutions. So, for instance, we want to sell more widgets. Maybe a way of, maybe a rule we could introduce is some kind of discounts. Something we introduce to try and solve our business problems, right? We want to start offering discounts to customers if they buy in volume. We think that will solve the problem. And then much, much later, we do some technical stuff that implements that solution that we came up with, which includes writing the code, which includes thinking of the architecture or thinking about how we're going to host this, or deciding are we going to use microservices to do this stuff. It also includes the UX, includes the specifics of how are we going to implement this. And ideally, once we then deploy this code, it implements these rules correctly that we talked about, and it solves our business problems. But all of this is kind of supposition and a hypothesis until it's out there in the world, actually changing the metrics. And depending where you are, depending what team you're in, you might only be involved down here. So is anyone in a team where they just get given all of the business rules and all the requirements, and they have to come up with a technical solution? Anyone? Yeah. Some people are in a situation where the technical solution's kind of half dictated to them by some other set of techies in the business. So even before they get their hands on it, someone's drawn the UML for them or drawn the system diagram. But moving left along this is a good way to get more directly connected with the products you're building and probably improve the quality of the software you're writing. So there's a whole field of behavior-driven development. So I guess this is the first best practice, is do behavior-driven development. Using Behat doesn't mean you're doing BDD. And there's a bunch of definitions of BDD. Dan North coined the term in the early 2000s, but he's got a really long definition. I like Liz Keogh's definition. BDD is when you use examples in conversations to illustrate behavior. So there's a few things there. One is that you're having conversations. So if you're not having conversations about the system, start. Conversation is when you're talking in two directions, not just receiving requirements. The other part is that these conversations are about the behavior of the system. What should the system do? What should it achieve? Who's it achieving it for? That kind of thing. We'll talk a bit more about behavior in a second. And the last bit is using examples. So this is the kind of preferred, you're having conversations about behavior, and the preferred tool for these conversations is examples. So you kind of deliberately introduce examples as a way of understanding things. So what's an example? I always look at Wiktionary if I want to know something. An example illustrates or explains a rule. So people in BDD talk about examples a lot. Give me an example. They're not doing that just for the sake of examples. They're doing that because examples are a way for us to understand what are the rules of this system. Rules are maybe a bit hazy and hard to understand, and examples are something concrete and easy to understand. So it kind of fits in here. We're trying to understand what the business rules are, so that the software we build implements the business rules. And the way we're going to understand these business rules is by giving concrete examples. If you implement a system that implements the business rules wrongly, what happens is, depending on how agile you are, a day later or 2 years later, you find out, no, the software didn't actually implement stuff the way it should have. The software didn't implement the thing we thought would have solved our problems. So here's an example of a rule. We charge our customer sales tax at a rate of 20%. There's an argument that sometimes you can just understand a rule. So this is a business rule, right? There's something we have to do to comply with the government. We have to charge tax. Who thinks they understand the rule? Just Frank. Yeah, admit it. You think you understand the rule, right? So maybe sometimes some things are just obvious. You look at them and you understand it. You've got enough context from doing this kind of thing before that you don't need to further discuss it. However, if we introduce an example, it will give us a concrete case so we can check we understood the rule correctly. It's pretty cheap to come up with an example in a conversation. You say, all right, so if something's priced at $10, we're going to charge $10 and $2 tax. So we'll charge a total of $12. And you just say that as part of the conversation. Maybe write it down if you want to get advanced. And then you're checking that both parties are understanding the rule the same way. Is this what you understood the rule to be? It might not be. So we've got two people. I guess this is like a subject matter expert and a developer. Yes?
So my immediate question on that when you said that is, in what country, and in certain countries, in what city?
Yes.
Or what state, in what city, in what part of the city?
But the rule's there, right? The point is...
There's a rule there, but that is dramatically incomplete.
We'll get to that.
Sorry.
So the point is that I thought I understood what this was because there's a whole other set of rules in my mind about how tax works, based on my experience and where I live. It might not be right. Once you're confronted with this example, it's easy to kind of go, that's not what I thought. That's different to the algorithm I had in my head. So this is like a subject matter expert and a developer, and they're trying to explain the rules, explain the business rules, or talk about the business rules. They might think, yes, I understand, but the thing in their head is wrong, because we don't have telepathy yet. Business rules are kind of like algorithms or code. It's like, do you understand the system? Do you understand the way things should work? It's very hard to check that your understanding is the same as the other person's understanding. And a way of checking is to generate concrete cases. So if I just explain the rule, we can misunderstand. If I generate a list of concrete cases, in this situation, this is what should happen. In this other situation, this is what should happen. It gives the other person in the conversation a chance to go, hang on, I ran that through my understanding and I got different outputs. It's almost like that. Maybe I misunderstood it wrongly and we should talk about this more. We should talk more about this solution. It may be you generate some examples and they read them and go, yep, that's what I thought. You can kind of cut the conversation off. So maybe I readdress, we talk a bit more, and I give some counterexamples. So now the guy on the left goes, she gets it now. We're talking the same. We've got a two-way exchange of examples, and we kind of feel like we're synced up, at least for the cases we thought of. So when I've got my US-centric hat on, the developer's, I don't know, comes from New York or something. You can say, oh no, you misunderstood. What actually happens here in this country is, if it's priced at £10, we charge £10, and then we have to record that some proportion of that £10 was the tax. Right, so there's extra rules in here. There's a rule that is the price of the item is the amount you have to pay in cash, which might be obvious to someone who lives in a country that works this way, but might not be obvious to someone who lives in a state in America where they charge tax on top. Certainly when I've gone to places in New York and something costs $19.99 and I've got my $20 bill in my hand, I get surprised when they say, like, that's $21.03. And they have to make crazy amounts of change. So what are the important parts of an example? Well, really, we're looking, what's the input? And then when we process it through the rules, what's the output going to be? It's kind of like a pure function, let's say. When this thing happens, what's going to happen? So the keywords that people use, you don't have to use the keywords when you're just talking to humans, but people often use the word when to describe the input, when this thing happens, and they'll use the word then to describe what should happen. So when this happens, this is what should happen. When I buy a pair of Levi 501s, then I'm charged $32.99, which is reasonably cheap for Levi's. So there's something missing here. You might feel it when you read it. It's not really clear why this leads to this. Why that number? Why does that product lead to that number? So there's kind of a third element, which is the context, the past. What happened before the conversation we're having? You can think of it either as what state is the system in when this action happens, or, if you like event sourcing and stuff, you can say what happened in the past, what events happened in the past of the system, so this new event is going to cause this new outcome. So given somebody entered Levi 501s, they listed them in the catalogue at $32.99. When I buy a pair of Levi 501s, then I'm charged $32.99. Simple. Once you have a few examples in the conversation, I want to emphasize this isn't a one-way conversation, but when you've got a few examples that you've talked about, you can start looking at them and questioning, exploring the requirements exploring the business rules in a few different angles. One is questioning the context. So I also stole this from Liz Keir. You can say, okay, is there any context where that action doesn't cause that outcome, where that input doesn't cause that output? So let's apply it to our example. Is there any situation, we've got this existing example, is there any situation where I could buy these jeans and pay a different amount? Let's just talk about that. And you'll come up with some new potential rules. Maybe they're on sale. We can talk about whether that's something we're going to do soon or something we can sort of shove into our backlog. Similarly, maybe staff members are going to get discounts. Let's talk about it. Is that something we're going to implement now? Maybe we'll do it later. Is that something you thought we were implementing now and we're not? X display. You come up with new topics to talk about how the business rules should work. Another angle is outcome questioning. So you've got some examples. We've talked about what outcomes happen. Are there other outcomes that also have to happen that we haven't talked about? This is a good way of detecting are there other parts of the business we have to interact with. So I bought some jeans. I've been charged. What else happens? I get given the jeans, so we have to think about packaging and dispatch and stuff like that. The warehouse has to be told that they have fewer pairs of this size of jeans than they used to. What are the other things that have to happen? What are the other thens that we haven't talked about? So you kind of explore these two angles and you just have a conversation until everyone's bored. And then you do your normal stuff of deciding which bits are we doing now and which bits are we doing later. But it's a kind of it's a way of talking about business rules that isn't vague. The rule behind this is when I buy an item, I get charged the correct price for that item. And there's a whole universe of misunderstanding inside that phrase, correct price for the item, between developers and business people. Generating some concrete examples like this, everyone involved reads them and goes, yeah, that's what I thought. That's how I thought it worked. Cool, we all understand. So that's a lot of behavior-driven development. BDD isn't really about testing. What you find is people doing this kind of exercise are technical people building software, so they're naturally going to get into stuff like automated testing or even manual testing. And you start looking at these examples and say, this is an incredible basis for a test case. Whether we're going to test it manually or whether we're going to automate, I've now got a really concrete example that once the system's been built, I should be able to list a pair of jeans at this price and then go and buy them, and that's the price I should get charged. So this is going to be a really useful way of generating test cases, but that's not really the conversation you're having and the way you're exploring requirements is really what BDD is about. But this is a Behat talk, and Behat is a tool for testing those business requirements. So we're kind of going to talk about Behat next. BDD also isn't about requirement capture. So it's not about the person from the business comes and delivers these examples to you. It's not about someone comes up with all these solutions, a business analyst writes out all these given when-thens for you and drops them on your desk and you sort of beaver away implementing them. That's not really what BDD is about. But what we're going to talk about next is about validating examples, so it's kind of a bit about testing. So we wanted to understand the business rules, we talked about them a lot, we generated these examples. Then once we've implemented our technical solutions, we're naturally going to write tests, because I remember 10 years ago, the idea of writing tests was like this crazy fringe subject that only lunatics talked about. But it's pretty mainstream now in development, hopefully. Who writes tests for their code? Yeah, okay, cool. We used to just hit refresh, which is a kind of testing, but it took a lot longer. And we can take some of these conversations we had, these concrete cases from the conversations, and use them as a basis for our tests. So there's a tool called Cucumber, emerged first from Ruby, in the Ruby world, that tried to take these written English sentences, doesn't have to be English, but I always say English by accident, and says, how can we take this written requirement and drive an automated test based on it? Before that, there were tools like Fitness and things like that. Cucumber now exists in most programming languages, and Behat is Cucumber for PHP. It doesn't really share the code, but we collaborate a lot across the different tools across languages, and the Cucumber company like to apply Cucumber, the name, to everything. So Behat was started by Konstantin Kudryashov, who's still the main developer, probably writes about 90% of the code. And it's interested in this intersection. We talked about all these things to understand what we're going to build, and also there's some stuff we'd like to write automated tests for, and where it's worth doing both of them, we're going to use this tool. You don't have to automate all the conversations you had, and not all of your tests need to be dressed up in this kind of clothing of English sentences. But if you're doing it right, there's going to be a big overlap. You're going to have had a lot of conversations, and they're going to have produced good outputs that you're going to automate. So there's a format called Gherkin. You don't need to read this slide, but just see the kind of syntax. That is a language. It's a format that's shared between different Cucumber tools. It's a way of capturing natural language requirements in a way that's parsable by all of these tools. The bit at the top is pretty much free text. So for each feature, here we're talking about a tool where we schedule training courses for employees, and the thing we're concerned with is, do we have enough people to run the course, or do we have too many people and we have to schedule an extra date? Then each scenario here is a different example from the conversation. So we'll zoom in. The bit at the top, I just explain what I think the business rules are. This bit isn't going to get parsed. But I show it because a lot of people using Behat don't write anything in this bit. This file's going to go into your code base. It's going to live there with the system, so it's a good place to document this is something the system should do. So the problem I have is I schedule a course and one person signs up and then we don't notice, and on the day it's really awkward because I'm training one person. Or the maximum capacity has been reached. We don't want extra people to sign up. We want to know about it, and we'll probably schedule some extra ones. And there's a background. This is kind of given steps that are common to all of the scenarios in the file. So instead of repeating yourself throughout the file, this is the stuff that's common. So given, this is the context, there's a BDD for beginners that was proposed with a class size of 2 to 3 people. Our first scenario is that the course doesn't get enough enrollment. So let's say only Alice enrolls on the course won't be viable. Okay? So because it's scheduled for 2 to 3 people, if only Alice enrolls, the course won't be viable. Another scenario, the course gets enough enrollments to be visible. So if Alice has already enrolled, at the point Bob enrolls in the course, then the course becomes viable. So there's a context, there's an action, and there's an outcome. And enrollments are stopped when the class size is reached. So if Alice, Bob, and Charlie have already enrolled in the course, when Derek tries to enroll in the course, he shouldn't be able to enroll. And none of this is about implementation detail, it's just kind of business detail. Remember, because these should all be conversations that you're having before you've thought about the technical detail almost, they don't really need to reflect any of the user interface because you haven't designed that yet. You're just talking about what the people involved, what should they be able to do, what actions should they be able to take. So the way Behat works is we have these feature files, and each step is a given when or then. It's going to run through all of these feature files. And for each step, it's going to find a PHP method on a class called a context to execute. I'm not going to go really deep on the detail of how to do it because there are documentation. I want to give you the idea of how it works. So when Behat finds a line like this one, given a thing happens to Ciaran, it then finds a method that's annotated with a pattern that matches the step. It will then execute this method. And that's pretty much all it does. So it's responsible for running this big loop of being a test runner. It's responsible for finding these feature files on disk. It parses them. And for each step, it finds what PHP do I execute. I have some placeholders here that get passed through. So any step that says given a thing happens to someone's name, this method gets run. And you have to write this code. So it doesn't test anything for you. You put your test code in here. It's basically tying up this outline of a test that's in English with a PHP code for each step. So how do people interact with systems? Well, they interact through a user interface, pretty much. So a lot of people will start their Behat testing through a UI. This leads to the misconception that Behat is a browser automation tool, and it is not. But if I'm going to have a kind of three-tier architecture like this, it's going to be more interesting to start at the bottom. I'm going to use my examples to make sure my domain model works first. That's going to be quicker. It's going to be quicker than waiting until I've built the user interface and then checking it works. I want to make sure the domain model works. I want to make sure the domain model supports the use cases. So that means inside each of those Behat methods, I'm going to just instantiate PHP objects and do stuff with them. This is going to make sure my domain model, and you quite often want to have a nice isolated core domain model. I'm going to make sure that that supports all of the business actions that I want people to do. This means that the logic that supports those business actions can't be accidentally put into the controllers or accidentally put into the JavaScript. The domain model is going to enforce the business rules. And it's going to execute quickly because it's just PHP objects. So let's see how we'd do it. I'd run Behat. It highlights everything in yellow. Yellow means you haven't told me what to do with this yet. So there's no matching step. It's complaining. It's kind of failing that step. So I have to start writing methods. So look, what's the first step? The first step is given BDD for beginners was proposed with a class size of 2 to 3 people. I then make sure there's a method, and Behat kind of generates a skeleton of this method. A method with a matching pattern. I put in min and max because I assume I might later have scenarios with different numbers. And I try and write in PHP code that kind of makes sense to model this sentence. So this isn't an object-oriented modeling talk, and you might disagree with the way I've done stuff. But I've basically chosen to define a couple of value objects, a course that gets proposed with a title, and then another object called a class size, which represents a class size with a minimum and a maximum. So I'm reading the text. This is how we talked about it. It seems like a good idea to reflect that into the PHP. Use the same words, use the same verbs, all that stuff. So now when I execute it, I get a fatal error because I've said there's going to be an object called course. In terms of my workflow, this means I know exactly what I've got to do. I've got to define those objects. I've got to add the methods that I called. I've got to make sure those objects can execute. And I would write unit tests as I go and do unit level TDD. And once I've written the course object and the class size object, that test will start to pass. So a step passes as long as no fatal errors happen and as long as no exceptions get thrown. So my job is now to look at the next step, when only Alice enrolls on the course. So I write a step when only the learner enrolls on the course. I say, okay, the course needs a method called enroll that takes a learner. And I can write this thing called a transform, which is a way of casting the string that's in the natural language into an object. So quite often we'll repetitively have to transform strings into objects. I'm assuming here I'm going to use a lot of learners. So the thing says only Alice enrolls on the course. It's going to take the string Alice and it's going to turn it into a learner. Depending on your system, you might need to fill in some other fields on the learner object or have a builder, something like that. You do all of that inside the transform. You want to make a user that represents someone called Alice. A learner, sorry. And then you enroll her on the course. And then the course will not be viable. So in the then steps, we want to deliberately throw an exception. We check something and throw an exception. So here I'm asserting that the course has an isViable method that returns false. You can use other assertion libraries. The PHP unit assertion library is a good one to use here. So once I've done all of that, and I've implemented all of those objects, this whole scenario will go green in Behat. So quite quickly, I've got a bunch of objects that support a particular action that someone wants to do with the system. And I've kind of aligned the naming in those objects with the way we talked about it, which feels like it's going to be valuable. So I run through the rest of the scenarios. I've got 2 more scenarios. And I find I can start reusing the codes. The first one, you have to create a lot of stuff. As you work through scenarios, some of the things already exist in the system. So this time I said, given Alice is already enrolled on the course. Well, I have a method that enrolls people. I can just add a second pattern that it matches. So this matches the same pattern as the first time. I've already written this object, I've already written this method, so I can get this passing quickly. When Bob enrolls on this course, that's actually the same thing. Again, it's just talking about someone enrolling. So I can modify the pattern so the only keyword is optional. We had when only Alice enrolls. Now I'm saying when Bob enrolls. That's fine, this still matches. So the underlying object model, we're calling the same method, we're just talking about slightly different variations. And the course will be viable. I need to write something that checks the course is viable. I already had checking the course is not viable, and I have to check the course is viable. So to make this scenario pass, I didn't actually need to add any new classes or add any new methods. I just hook stuff up, but I'll find that the new logic isn't implemented. So in the first step, I checked the course was viable. I could have hard-coded return true into that isViable method. Now I've got to here. Everything worked. Everything executed. All the methods were there. It's just it output the wrong result. So now I'm going to have to go and fix my object model, maybe write some unit tests. Maybe add some actual logic into this isViable test. And do some stuff in the value objects. So that's all passing. So we basically do the same thing. When I want to enroll 3 people, I call the enroll method I already wrote 3 times. I'm just matching up these steps. Notice I don't really edit the English language steps to make sure it's always written in the same way. I think it's more important to capture the way we talked about it and make the PHP reflect the way we talked about it. So the third scenario, there's 3 people sign up, so I enroll all 3 people. When Derek tries to enroll on the course, this is slightly different. It tries to, so I'm going to call the existing enroll method, but I'm going to wrap it in a try and catch any exceptions that happen. And he should not be able to enroll. We'll just insert that an enrollment problem exception got thrown by the previous step, which will fail because it's not throwing the exception, and I have to go in and add some logic. By the end, I've got all of these scenarios passing. So we've created 2 objects there. We've added a bunch of methods to them. We've had to implement some of the domain logic. I didn't show it, but you would have also written a bunch of unit tests for those objects as you go. So we've got a domain model that will enforce this simple business rule that you can't oversubscribe, you can't undersubscribe. It's enforcing that inside the course object. The course object's an entity. It's got its business rules inside, it's got its own responsibilities. Because I didn't let myself implement the controllers at the same time and all that stuff. So I'm going to be able to use these objects in any context. If I'm going to be using them in an application, I probably want to add a service layer. Now, application services, this is. If I have a beautiful domain model and I have a whole load of controllers, and all of those controllers are directly using the domain model, they're directly instantiating objects, calling methods, this restricts me from refactoring the domain model. So when I later need to change the business rules, I might need to then find all the controllers and find all the places I instantiated that. I've got a class size object at the moment. I might decide to change the way I've modeled it. I then need to find all of the places that instantiated a class size object. So I'll quite often introduce an application service layer. We can use Behat to test this as well. So to drive a service layer, we need to configure services, application services that are able to do business actions. I need to inject them into the Behat context object. And instead of driving the domain model, I'm going to go up a layer. I'm going to just call methods on the service layer that then do stuff in the domain model. What's this going to achieve? It's going to help me build this layer for a start. It's also going to make sure that the services have methods that correspond with the steps in the scenarios, which might not sound like an obviously good thing to do, but the way we've talked about the system is we talk about things like when I approve an invoice, when I terminate an employee. If we align those with the services, we'll have a nice service that's called approve invoice that just takes some primitives. We'll have a nice service that's called terminate employee. This takes a bunch of primitives. The API of the service layer will start to conform with the actions people take, and this generally works out well. So how do you do it? In Behat, we have a concept of suites. So previously, I was writing all of those methods in an object called domain context. I can tell Behat, I've got a second suite which has a second class that has a whole other set of step definitions. You should run my feature, first off matching it to this class, and then run the same feature again, but match the steps to a different context. In practice, you would use tagging to kind of segregate some features tested at the domain layer, some features tested at the service layer, some at both if you want to. I then, I'm just going to show a brief example. In the service context, I match the same steps again. But this time, instead of interacting with the domain objects directly, I assume I've got a course enrollments service that just takes some primitives. I can just tell it to do stuff. How does that get into this Behat context? It's passed in the constructor. How does Behat access a service? It depends how you're configuring services. Sometimes on a simple system, you can just instantiate the service in the constructor. Other times, you'll want to pull it from a service container from your favorite framework. So in Symfony, it looks like this. You say, this context that's configured, it's going to get a parameter course enrollments that is this service from my service container. And because I'm using the Symfony extension, the Symfony extension is responsible for plugging Symfony's container into Behat. So my context I can write like this and just get the correct service injected. If you're using different frameworks, there's some PSR11 support. Behat on its own can, without any extensions, Behat can deal with a container that can just be instantiated. So if you're using a container that you can just say new whatever, Behat will be able to plug that in natively. As part of implementing that in Behat, there's an extension point that makes it easy to plug containers from other frameworks into Behat, as long as they support PSR11. So I helped build this extension for Zend Expressive, because Zend Expressive has a file that returns the container, and we needed a way of loading that in. So you can generally find a way of getting your service definitions and then getting Behat to interact directly with the services. A new feature in Behat recently is auto-wiring. I've not tried it yet because it doesn't work with the Symfony extension. But in theory, you can get rid of some of that config file and just type hint things in the Behat constructor, Behat context constructor. As long as you're using a container that names the services after the class name, that kind of style. And the service would just look something like this. The service itself would use the domain objects and would use probably a repository. So when I propose a course, it's going to instantiate a course and it's going to add it to some sort of repository. So generally at the service layer is when you start thinking, actually, I'm going to have to deal with some infrastructure here. I'm going to have to save stuff occasionally. It's not all just objects all the way down. So using real infrastructure, plugging these tests into your database is going to slow them down dramatically. If you saw the talk about React earlier, there were some nice stats about the difference in speed between I/O and CPU execution. Using real infrastructure is going to really slow down your test suite. We have people come to us for consultancy and say, we've got a test suite that takes 5 hours because we recreate our Oracle database every time we run a test. Even when you do clever stuff about swapping fixtures, it's always going to be dramatically faster. It's not going to be something a developer can just run every time they hit enter. Every time they save a file, they run it. That's kind of where you want your test suite to be. So you probably want to use fake infrastructure, not the real stuff, but using fake infrastructure can lower your confidence. So a strategy I tend to do is to have fake versions of all my infrastructure, but then have contract tests that are synchronizing the two. For instance, if I have a user repository, that's an interface. Let's say users, I have to be able to save users and find them by email. In production, I'm going to implement that in Doctrine or something like that. In my tests, I want a version that can just store stuff in memory, in an array. Now, how do I make sure they behave the same? I'm going to write contract tests. So I'll have an abstract test class. I'll use PHP unit for this, by the way. An abstract test class that has a bunch of test cases, and what makes them contract tests is they only use the interface. So test users can be found by email, would instantiate a user, save it, and then find that user by email, and check the same user pops out. I'm not doing anything that betrays that I kind of know how it's being saved. I can then extend that test, and really all I implement here is setup and teardown for however I'm storing that user. And then that will test the in-memory. So the in-memory setup is just instantiate an object. The setup here might be, create a test database. The fact these tests, the same test cases are running against the two sets of infrastructure, the real and the fake, means when I test something with a fake infrastructure, I'm much more confident it's going to work with the real infrastructure as well. If I'm doing acceptance tests across a whole bunch of features with a real database, let's say, often when you analyze the database access, you find every acceptance test is doing find by ID repetitively across the database. If I have a contract test that tells me, find by ID works pretty well, I'm then happy plugging in a fake version of that database that isn't going to execute against a real disk. That's a bit of a digression. So sometimes I write something very trivial like this. This is a repository that stores courses. You can save a course, and then you can find it by title. And on the day that I write a test that has more than one course, I'll bother checking the title. But for now, this is fine. And I can verify that behaves the same as the database when you've only got one title. So only Alice enrolls in the course. I'll then write an enroll method that just takes the learner as a string and the ID of the course that we saved previously. And the course will not be viable. I write a method that tells me, is this course viable on the service? So now we've got a service that uses the domain objects we built in the previous step, but it uses them, we're testing through the service to check the domain objects still work. And if you look at the methods that we've added to the service, which I now realize are spread out across a few slides. Yeah, okay, forget that. We've got a method that registers a new course and it just takes primitives, including saving that course to the database. We've got a method that adds a learner, enrolls a learner on a course that just takes primitives, including any database access. I've got a method that asks, is this learner enrolled on this course? Where all of the knowing which repository it depends on is all internal to that. So these are great when I now come to build my UI. So when I'm building my controllers, I have methods that correspond directly to things people want to do. And my controllers are just calling methods on services. They don't worry so much about persistence. What's helped me do that is this act of matching everything to sentences. When we talked, we had a discussion about the business rules, and we used the phrase, the course won't be viable. And 4 hours later, I've done some object modeling, and I've got a service that is the course viable as a method that works. This is pretty powerful. So these two layers feel duplicative. It feels like you maybe shouldn't test at both of these layers, and what I find in practice is I bounce between them. So a particular feature, I'll often start, as we just did, by driving the domain layer. So I'll start by driving the PHP objects directly. This helps me use the words from the description in the naming of the objects, in the naming of the methods. I'll then refactor it so we're testing through the service layer. So I'll kind of write a service that uses the objects we just made, and I'll move my Behat test to test through the service instead. And then when I feel like I need to change something about the domain layer, I'll often drop back to the domain layer and drive that directly again from Behat. For instance, if we have some new features, new requirements. Because we've got such a simple API on the services, we can completely change all of the objects in the domain layer as long as we maintain that service contract. All of the controllers and things that use it are going to be fine. So then finally, the thing 99% of people use Behat for, which I'm going to say isn't best practice. You probably want to check, I thought I only had 5 left. Oh, I'll talk slower. You probably want to check that your system is going to work end-to-end with a user interface with the real database. So you probably want to write end-to-end tests. However, this is like the last thing we do, and we've got a different mindset here. I know that all of the things people want to do are supported by the service layer. And I know from my contract tests that all the things people want to do are supported being saved into the infrastructure. I'm pretty confident. So I'm not going to then test all of that stuff again through the UI. What I really want to know now is the user interface plugged in to my beautiful service layer that I just wrote? So I know the service layer works. My question is the UI plugged into it? And most of the time, you don't have to run all of the examples through the user interface. So when I get a new keyboard, I'm going to plug it into my... OK, at work, I've got a Bluetooth keyboard, and inevitably, the batteries die over the weekend because I forget to plug them in. So when I come back in, I have to reconnect. And then to check it's working, I just kind of go like this. And if some stuff appears on the screen, I'm pretty happy. Or I type a word. Well, normally I type in my password. I know there's a lag and the password field gets populated. Once that happens, because I know the computer works, I'm confident that this is connected to the computer. I don't try every single thing I might ever want to do with a keyboard exhaustively before I'm happy the keyboard works, right? Because I've got a certain level of confidence that in the existing system. It's the same here. Imagine a pricing thing on an e-commerce site where we've got like really complicated pricing rules. And we've got a user interface where people can add things to the basket and look at what the total price is. If one of those scenarios works end-to-end through the user interface, then it tells me the user interface is plugged into the thing I built that generates the total price. And I know that thing applies all the pricing rules. So I'm probably only going to run one of the scenarios end-to-end. Even if there's 50 scenarios that explain if it's a Tuesday, everyone gets 20% off. I'm pretty confident that all works. I'll run one through to check the UI is plugged into that system. So like when I click Add Product to Basket, does it call the right service? When I choose to display the thing on the screen, does it call the right thing on the service to pull the right number out? So how we do that, I mean, we're not even at the point where we're thinking about real web browsers. God, that would be super slow. We'll talk about that later. We can probably drive the UI layer without using a web browser. Behat has an extension called Mink extension. Mink is a standalone browser automation abstraction layer. The idea is there's loads of browser automation tools. They've all got different APIs. Mink kind of sits on top of them all and has one API for everything. So Mink is good if you want to write browser automation code, and you might switch between Selenium, between curl, between something else, without having to rewrite all of that code. Generally, what we're checking when we check the UI is we're checking the UI supports the business action. So we know the service layer supports the business action. We're checking the UI is kind of hooked into it. UI tests are normally slow, orders of magnitude slower, because we're going to involve databases and sometimes, God forbid, web servers, and sometimes actual browsers spawning windows open. They're brittle because they depend a lot on the UI. UI tests tend to have things like CSS selectors in them, and front-end developers don't know which bits you're using in the test, so they rip it all out, and the tests start failing, and someone has to fix it. And they're flaky because often there's real systems involved that might time out. Or, I mean, your real database might be used by, you might not be able to have dev databases. Some people are in that situation. So you have to write tests that don't contend with each other if multiple people are running tests. You might have one dev database for the entire organization, like one of our customers. If we only did the UI layer, our object model could be shit. We'd just be checking the UI supported things. And if you saw the talk earlier about testing legacy systems, if you've got a shit code base, you can just test through the UI and sort of take that hit and pay that price that it's going to be slow until you can improve the big ball of mud in the middle. But if we've got a good domain model and we've got a good service layer around it, we don't need to do that much UI testing. Don't do this. Behat has this, Mink extension has this built in. There's a set of predefined step definitions that do UI automation tasks. It's for people who want a quick way of writing UI automation tests that are kind of dressed up as sentences, but this is nothing like a conversation you'd have with a human being. Have a conversation with a person, talk about the business. Don't do this. So because Mink supports multiple browser drivers, importantly, we can take advantage of some of the tools that framework developers have built to test their frameworks. BrowserKit is what Symfony uses to test end-to-end UI without actually running a web server. What it does is it instantiates a request object, runs it through the application, gets a response object back, and then checks things about the response object. That's good enough, as long as you trust that you trust your web server receives HTTP requests, and you trust that someone set up a rewrite rule that points to Symfony. As long as you trust that bit, then testing just the framework with request and response objects is going to be good enough. So how that looks is I'll add yet another suite. I'll probably tag it. So only scenarios in the gherkin that have been tagged that this one needs to run end-to-end are going to get run end-to-end. They'll run through the domain context first, and then the service context, and then they'll run end-to-end. And then with the Symfony driver, I'll have to use the Mink extension, which is the browser automation extension, and I'll tell it that the Symfony extension registers a Symfony driver, and then I tell Mink extension, use the Symfony driver. It was badly named. It does work with Symfony 4 and 3. But you can't change these things. Legacy problems, right? We were talking about IE6 earlier, right? Once you name something, you're stuck with it. If you use a framework that uses PSR7, there's an extension I wrote that lets you do the same thing. So if you're using Expressive or Slim or anything else pretty much that supports PSR7, you just say, I'm going to use the PSR7 driver, and you have to write a file that kind of returns your application. But that's pretty straightforward if you've already got an app. And especially with Slim and Expressive, you just return your Slim application, bootstrapped. So now inside our context, we write, we match the same steps, but instead of calling things on services, we write browser automation code. In the given step, we can still interact with the service, but we'd interact with the real service that stores things in the database. It's okay to cheat on the given step and not go through the UI. So you're saying this is the state the system's in. We can shove some stuff into the real database. When I say a learner enrolls on this course, I have to write some Mink automation code. So what does it mean to enroll on a course? It means you go to a particular URL. It means you fill in your name on the field, and it means you press enroll. There might be a login thing on a real system, but you think, this business action, what is it in terms of interacting through the UI? And the course not being viable, previously we were doing stuff with services. A course not being viable in terms of the UI is when I go to this list of courses, there's a warning saying this course isn't viable. So I'm really just checking, when I push this button, that method on that service I previously defined gets called. And when I look at this page, it shows a page that has obviously looked something up using that service I previously wrote. So the last thing you might have to do is automate a real browser. You might still feel, maybe that doesn't do it for me. Really try and minimize it, because even though this kind of framework-based request response testing is much slower than testing services, automating a real browser is a nightmare. It's tens, if not hundreds of times slower. Things crash, Chrome stops running, or Selenium stops running, or like the connection times out, or the JavaScript injection fails, and you just start regarding the tests as something that fail occasionally. If we rerun them, we'll be okay. Maybe we'll be lucky this time. It can be required if you're writing a single-page application and only the PHP team care about testing, because then you'll have to test it using a real browser that can execute the JavaScript. If you've got if the people writing the JavaScript are kind of into the idea, you can do exactly what we just did in Cucumber.js. So you don't have to test end-to-end just because it's JavaScript. You can have this might be a newsflash to some people. You can have a domain model in JavaScript. You can have, objects and things in JavaScript that have nice, clean boundaries, and then plug into a DOM. Then you can test things incrementally, sort of separate pyramid of tests on the JavaScript layer, and only test a few things end-to-end. If you have to do it, this is my current sort of best setup. So you add a Selenium driver. Chrome is the fastest for me at the moment. Chrome now has a headless mode as of Chrome 40. This goes about twice as fast as Chrome not in headless mode for me. Even when I was running Chrome in like a headless virtual frame buffer environment, this is probably about twice as fast. So things I'm trying out for the future. This person, Dorian Moore, has written a Chrome extension that doesn't use Selenium. You run Chrome as a server, and it talks directly to Chrome's debug port. This is, again, twice as fast as running headless Chrome through Selenium for me. I haven't helped out because it's on GitLab, and I don't know how to do pull requests, but it looks good. And I'm interested in whether the end-to-end tests can implement the same service API, and I'm interested in integrating property-based testing into this stuff. So in summary, start by driving the domain objects, refactor to services when you feel that's stable, add a little bit of UI coverage, but don't start there. I'm Ciaran, I work for Invika, I look after PHP Spec, I organise 2 meetups, BDD London, and I help organise Symfony UK. A code base for all the code from this talk is online. Please review everything on Joined In, and I know for a fact there's no time for questions, but thank you very much.